this energy meter and solar charger controller VAC8010F-500. There are different versions of it, 50, 100, 200, 300 and 500, and I have purchased this 50 ampere. This is a wireless display that you can power it up from battery bank or whatever. Up to 20 meters you can get away from this, keep it in a distance. And this is based on this Hall sensor, so you don't need to cut the wire, just pass through this. You can measure voltage, current, power, capacity, energy, time, and then under voltage protection, over current protection, over discharge current protection, and so many other features. Let's get started with this. This meter, the VAC8010F, which can measure up to 120 volts, and this is a 500 volts model and 50 ampere, but you can get 100, 200, 300 and 500 ampere version. This uses a Hall effect that you can pass your wire without cutting it, so this can measure and then remotely display it about 20 meters away on this screen. This can be powered up via USB, and also this can be powered from 6 volts to 80 volts, the operating voltage of this, but it can measure up to 120 volts from here, with your power. But if your power source is between the range of 6 to 100 to 80 volts, then you can connect it to here, and we just move this jumper to the other side, and you don't need this power. From the same power it will power it up, and we can measure the voltage, current, power, capacity, energy, and so many other protections, including time, under voltage, charge current protection, over charge current protection, over discharge current protection, over voltage protection, under voltage protection, and then it also shows the battery capacity and so many other features, which makes it very useful. I bought this from AliExpress. So many stores are selling it. I'm going to provide you the link, but if you select shipping from China, 80 ampere, it will be $32, and if you go even with 500 ampere, it will be few cents more, $33.26 with $4 shipping. I will provide you the link with some savings. The link is below this video. This was the package that I received. Let's open it. We have 2 micro USB cables, 3 of these 2-pin connectors, and then this is USB to USB. So they just wrap it in a plastic. Here, this is a display with 5 module. And with that, this is the sensor. The actual sensor is connected to this, and accordingly you have to select the right one. Now let me explain the hardware. So this is the sensor, or the Hall effect sensor. Here, these are the wires. We do not worry about it. This is a temperature sensor here. So if you're monitoring something, just attach it to something, MOSFET transistor or whatever you have. So it can be immersed also in liquid. That's very nice. This has a screw that you can attach it to something. Here we have the following pins. Labeled as out is to control a relay for discharge. This is in, this is for charge. The USB, from here we can power this device. So I can connect it directly in here. So this is powering your display if it is close by, or you can go up to 20 meters away based on this communication. But if it is open space, it might work a little longer. This is for power supply, 6 to 80 volts. You will connect your voltage to power this up. If the voltage is between the voltage that you are measuring is between 6 to 80 volts, then you can connect it in here, and do not connect that, it will power this up. But if you want to go less than 6, let's say 5 volts, 2 volts, whatever, then you need to have separate voltage for this to operate and work. And this is the 2 wire that you're connecting to your source that you're measuring the voltage or current. Not powering it from the same wire. And if you want to power it up with using this, not with this wire, make sure to remove the jumper and put it the other way, like this. So I have removed it and put it in the other connector. Then at this case we don't need this, only this wire will work. We have direction. If the current is if the power supply is here and the load is on the other side, if you put it this way, you will read positive. But if your battery is on the other side and you're charging something, you will be draining from the battery, you will read negative. So whichever current flows, if it flows this way, it will be positive, this way negative. Pay attention to that. Now this is the display. The display is very simple, and this is the main module that everybody is using it. We have only 3 buttons. Now let me show you how this works. Here we are reading the voltage. Here we will be reading the current. Here it will be the power. So these 2 will be multiplied, will be written in here. This is the capacity of your battery. You will set the capacity that you have, charging it or discharging it, so you can monitor it. This is a kilowatt hour. So amount of current per unit of time will be calculated in 1 hour. How many watt hour multiplied, and the unit of time will be calculated in here. This is the time that will calculate drain or amount of current that you are running. So it will tell you, but this was very not clear. I did not understand it. Charging it or discharging it, so you can monitor it. This is a kilowatt hour. So amount of current per unit of time will be calculated in 1 hour. How many watt hour multiplied, and the unit of time will be calculated in here. This is the time that will calculate drain or amount of current that you are running, so it will tell you, but this was very not clear. I did not understand it. This is the temperature which is coming from this sensor, and this is the time. As soon as the load starts, the time or counter will start running. The percent is for the battery capacity. It will show you in terms of graph, and it will show you the value here, which I'm going to show you next. So this cursor can move, this dot can move with these 3 buttons. The middle is OK. This is increase, decrease, or up, down. So some numbers, strange letters have been picked, but let's talk about it. This is the overcharge protection. This is the charge over current protection. When you charge, that is over current protection, and this is the discharge over current protection. The charge over voltage protection, the discharge under voltage protection, because some batteries will get damaged if you drain the voltage at below certain level. And this out means when you control the relay that are connected to these 2 connectors. And here I've connected LED with resistor built in, so I've labeled them as charge and discharge, so I know which relay is being turned on and off by the device. And here, if I'm in out, and if I press it, and here if I press it, I can switch it with this switch on. Charge and discharge can go switch with this. bring this down, and now we are out. Pay attention to the LED in here. Out, on. You see the next one on. So there are two LEDs. Let me go back to the other one. So you see that, the red LED. So you can switch either for charge or for discharge relay to turn it on and off and see it. And for each we have the same value, the same way to set this up. This is for the charge over current protection. Once you brought the dot in front of that, press this OK, and you will see this screen. The number that you set here is for the amount of current. For example, in this case, it says up to 100, but our sensor is 50. So this will go up to 50. We should not set it above that. And this is the maximum current that we allow. Otherwise, it will turn on and off the relay. It doesn't do anything else. But so here, if you want to set it, let's say for 20, pay attention. Do not worry about this. I'm going to explain it. I'm just holding it. So I set it 23.3. Now it shows 233. There is no dot, so just assume a dot. But that's nice. This reading is from the sensor. This is your setting. It goes to that and sets. It comes back. So they didn't bother to put a dot because one dot would have pushed this way. Maybe they needed it on the left side. Whatever the reason. So this is the value. Once you set it, press this button OK and exit. So now that is set. When the charged current goes above 23, it will turn on the relay. Now let's go to the next one. Oh, let's go exit first from this screen. Now when you go down, it is the discharge current. The same way we can set the discharge. Right now it's 13. I'm pressing it to exit. If I bring the cursor down, it is now low voltage protection. This is the discharge under voltage protection, which means the battery voltage. If I press it, here this screen says 26, and you can set the voltage. When the voltage is below 26, it will turn on. To make it not active, to disable it, just make this 0. Let's put it as 0. Now this is 0 and this will be disabled. The same way all of these can be disabled if you set them to 0. This is over voltage and this is under voltage. Press it 0. 0 means disabled. Press to exit and then go down. This is out. And this LCK, this is for lock. So if I right now, you see the button goes up and down. If I press it and hold it, now it's red. Now it doesn't work, so it is locked in here. To unlock it, just hold it for a few seconds. Now it's unlocked, but we didn't see any sign. This is for the battery capacity. When you're here, press it. And here the battery is 0.5. Let's put it for some value. I'm pressing and this plus. Right now this is 18.6 ampere hour. 18.6, so that's ampere hour capacity. And then press this to exit. Now we set that, but we have to set the battery charge level. How much is it's filled up, or how much energy it has at the moment. So it is 0%. Let's make it 100 and this color will go. So now 95%, 100%. So the battery is 100% and here it shows 100. If I go down, this number reflects that graph. Whatever you set here will be displayed here and here. Let's go up, make it 100 back. and then press OK to exit. Now the 100% shows an 18.6 ampere hour battery is there. If you drain the current, if this value is negative, it will start working because it's draining. When it is positive, battery is charging. In here, this is like calibrating the current. For example, right now there is no current and we are reading 100 milliampere. When you're in here, just press it and hold it. Yes, so this is now 0. That is very simple calibration. Make sure that there is no load. Right now it is no wire is passing through this. So if we go down, this is for resetting this time. And now you can see here, it shows 7 over this much. That is based on amount of current for the battery. It shows at this much time it will be drained. If the voltage is 0.2 and the current is some small value, some minuscule value. So if you want to reset this and this watt hour, this time, while you're in RTE, just press it quickly and it is done. 0, 0. So we have reset it. Now go down. If I press this, this is for language, English, Chinese. So I can go up. I can go up. So it says Chinese. Come down, English. And then exit. Now let's go here. STI. This STI is the default relay power on. When you turn this on, the relay will be by default on, regardless if you turn it on or off. So we can go here, make it off or on. So off, exit. And SFH, that is searching for channels for communication between these two devices. If I press this, it shows 042. That is the address. The address could be 0 to 125, and it will find it automatically. Or you can select or search if you have multiple devices, so you can set different channel to make it work. But this is already set to 42. So press and exit. Now, if you go down, the delay time for the relay. When the relay is turned on, then you can set certain amount of time. For example, if the current increases beyond certain value, you can say that the relay should be on only after 10 seconds or 20 seconds, whatever amount of time. And here it says 0 seconds, so it means we can go up to 99 seconds. And this is FCH. This FCH is a communication address, 42. This is for searching for channel, exit, and this is for setting the address. And then we have SNR. This SNR display never turns off. There was no proper explanation. Okay, exit. And now SNT and works in conjunction with SNR, and then we have RFS. This is the reversal of screen color. If I select it, it says yes and no. Let's change it to yes. It says yes. Now exit. You see the background is white. I'm disconnecting it, and let me connect it back. Now background become black. So that was for this value. If you set it black, if you want to save energy, black will consume significantly low energy. So if you're concerned with that, let me go down and change it. And then exit. And let's have a look at the manual here. So the voltage for power this up is 6 to 80 volts, and the voltage that it can measure up to 120 volts. The range for the current, it says 100, but depending on the sensor. And here are some of the specs measuring range, voltage, current: 10 millivolts to 120, 100 milliampere to 100, and the capacity is for 65,000 ampere hour, and that is 100,000 kilowatt hour for the energy. Time is 100 hours, and power is 999 kilowatt. Temperature, voltage, accuracy is plus minus 1% plus 2 at the value, and then plus minus 2%, so voltage is more accurate. Measuring rate is 5 times a second, and relay delay time can be set up to 60. I was reading it up to 100, but that is correct, 60. For over voltage protection, we can set it up to 500. Under voltage protection, 500. OPC, charge current protection. NCP, discharge. As you can see, they have discrepancy here. OPC, charge carrying over current protection. That's for the charge. That is for the discharge. On the data sheet, this has been labeled as 1 discharge relay control, and number 2 charge relay control. So charge, it says in, and this has labeled as out. Connection that it says remove this connector on the left side. That's what I just explained. And then if you want to have separate power, then move it to the right side and then connect it. I will provide you this data sheet. This is for voltage. You're controlling the voltage of the relay, and this is for under voltage protection. This is for out when you connect it to the load. So you want to make sure it's not going below certain value. It's just for voltage, under voltage protection. That is for discharging battery. The whole current for the battery passes through this, so we want to make sure that the amount of current is within the limit or within the capacity. Just explanation of the device. Here I've connected the sensor, the meter, and this is the 8 gauge AWG wire passed through from my battery to the load, and from here I have separate USB power. It shows 12 volts, current is 0, and I've labeled these. I was not able to make them work, either they're defective or some setting. So these LEDs charge and discharge. So even though you can see it, but I put magnifier so you can see the current, the voltage, the power. I set the range for my electronic load at 50, so I cannot go above 50. I'm going to go with 1 ampere, and let's turn on the load. So 1 ampere is being drawn. Let me show you here. The direction of my wire shows the polarity. This shows 960 milliampere. The voltage is shown very accurately. So let's go 10 amp, and here it shows 10 ampere, and we are reading very accurate 20 milliampere deviation. And this cable, as you can see, this is going that way, so from my power supply it goes the other way. If I now remove the cable and put it from the other direction. Now we will be reading positive. So it changed the value now, 10 ampere. The voltage also good. Let's go 20. Now it's 20 ampere being supplied by load, and this is now measuring it wirelessly. So if you connect it to a battery source or something, power this up, this is the module that is communicating. So we are reading 20.26, 260 milliampere deviation from what it is. And here, let's go 30 ampere. So now 30, 320 milliampere deviation. This is lab equipment. This is very accurate. Let's go 40 ampere. Now 40, and we are reading here 40 ampere. So you can see also the voltage. Because we are passing through this as a Hall effect, there is no heat or any loss, and also no wiring or anything, just passes through, which might be a little hassle for some people to cut the wire, but that's a catch. Now let's go with the maximum 50. So the current is 50. Now we are reading here 50. This is very accurate, so this means 500 milliampere, 20 volts, 19.29, 19.7. So we see some deviation here. That is 1 kilowatt it shows, and here the correct value is 964 watts. Drain a battery. If I scroll down with this point, come to the battery and press enter, we can set here the battery capacity. I've set it to 1 ampere hour, and you can see 1 here. Do not worry, just remove 1 digit or maybe put a decimal point and read it. So that is the setting from the device itself. So I'm pressing this to exit and go down in here to set the capacity amount. So what is this capacity? 100%. So pay attention. If I make it at 40%, you see this changes. So let's go 100%. So we have 100% and exit. Now if I put it at 50, it will be very quick. To drain battery, now we have to change the direction of this cable. My wire is going that way. Now I have to remove it and put it the other way so we can drain the battery. So let me put it through this now. Put this on, and it is at 50. Now you can see the battery is being drained. The capacity very quickly. So let's see. When it says output off, it means the charge and discharge relay is not being controlled, but I can turn it on here. So it will not affect anything. As you can see, the battery is being drained. Now let's see what happens when it reaches at the end. So battery is fully drained. In this case, we could have set the relay to turn off the battery or whatever we have. Now let me set this to less than 1 ampere, 500 milliampere, and exit. So as you can see, we have timing, so we have to reset this by going down and RET and press it quickly. So this is resetted, the time is resetted. Go back. So I forgot to set the capacity, so let's go down and set it to 100%. So now the battery is full. Come back, and then let me turn it on. So now it's half of the capacity. It should go very fast and we can see it. And the LED is on, which did not work for me. So 0. For conclusion, I would say that these labels are very confusing. For example, this is charge over current protection, the N. What does it mean? This should have been labeled differently, but N doesn't make sense. And the same way over current protection, this is supposed to be, but this is discharge over current protection. And over voltage protection, this is the same way. Majority of the labels, for example, if we go down and here, this is reset, RST would have been better, but RET, and then STI, SFH, so bad. These have been labeled very badly. Even the backslash, perhaps this needed to be forward slash. So the design is bad, but in terms of voltage, current, very accurate. Capacity, I tested it, very accurate. Majority of the features work. The relay did not work that I tested. I did. Maybe the manual was not good, or maybe I did not understood it properly. But voltage, power, capacity, and remote display, all these works perfectly. So it's up to you. If you want to purchase it, I have affiliation link below this video. You can click and purchase it, and maybe it will be useful for some of your application. Thank you for watching. This was the review of this module. Please thumb up the video and also make sure to subscribe and put some comment, just small word. Really appreciate it because it will increase the rating of my video. In this video, we are going to do the review of this 50 volts, 20 ampere VAC WZ5020L back converter. 20 ampere or 1 kilowatt. We're going to test it at different voltages, up to 55 volts at the input and up to 20 ampere. Needs more current, so the constant current is turned on, but we are not worried. Input current 10.8.